Okay, fine. So today we will see the definition of the terms, that is specific resistance and conductivity. So we know already that the resistance of the conductor is given by R is equals to rho into L by A. We will even check this later. And yes, if L is equals to 1 meter and A is equals to 1 meter square, then if we substitute L and A in the equation R is equals to rho into L by A, then R will become which is equals to rho. So a resistance will become the resistivity. Okay. So the definition is like that. The resistance of a material having unit length and unit cross-sectional area. Okay, the resistance of the material having unit length and unit cross-sectional area is known as its specific resistance, or which is also called as resistivity. Okay, and it is given. So here if you observe, there is a resistance R, and this resistance, it is a conductor. It is a conductor. The resistance is R, and the conductor length is 1 meter, and its cross-sectional area is 1 meter square, then we can say the resistivity is equal to the resistor. Okay. So rho is equals to R. And the units of rho, that is resistivity, is ohm meter. Okay. So resistivity, I can write, means we can write in a formula that we know that already R is equals to rho into L by A. So from this equation we have to found what is rho. So rho is equals to R into A divided by L. Okay, which is equals to R is ohm, A is meter square, L is meter. Meter will get cancelled. Then the final unit is ohm meter. So rho units is ohm meter. Likewise, there is a conductivity, that is a specific conductance. Okay. So the reciprocal of resistivity of any material is known as conductivity. Okay. The reciprocal of resistivity of any material is known as conductivity, and the symbolic representation is, this is psi, and it is measured, the measured units is mho per meter. Okay, this we will call it as, which is reciprocal. So this is O and this is mho. Okay, mho per meter. So the reciprocal of resistivity is conductivity. So which I can say 1 by rho. Okay, 1 by rho is conductivity. Okay, there is a word conductance also, like resistance. Okay, where there is an existence of resistivity, there is resistance R. Likewise, there is a conductivity. So we have a term conductance. Okay, so we know that the conductivity is a reciprocal of resistivity. Likewise, the conductor is a reciprocal of resistance. Okay, so reciprocal means 1 by R. Okay, and this conductance is denoted by capital G. Resistance is denoted by capital R, and conductance is denoted by capital G. Okay, so G is a reciprocal of R, so G is equals to 1 by R. Okay, and yes, it is measured in Siemens. Siemens is also called as mho. Okay, so the units is mho. Resistance units is ohms and conductance units is mho. Okay, so now we have gone through the specific resistance, that is resistivity, specific conductance, conductivity, and the conductance. Okay, now we actually already know that R is equals to rho into L by A, but still we will see how this relation is given by, okay, the resistance offered by a material depends upon the following factors. See, always remember that the resistance will depend upon the length and the cross sectional area and the nature of the material and temperature. So we will see how actually it will depend. Okay. Yes. So here the resistance R of a conductor is directly proportional to its length and inversely proportional to its cross sectional area and depends upon the nature of the material and changes with temperature. So these four things you have to remember how the resistance will depend. Okay. So from these points, so we can say that R is directly proportional to L and inversely proportional to A, and it depends upon the nature of the material, that is the resistivity, and it also depends upon the temperature. So resistance changes with the temperature. Okay, that is also there. So this is how R is equal to rho into L by E. Okay, so we will see a simple problem on the above formula. So here, find the resistance of 100 meters copper wire which is having 0.05 centimeters in diameter and takes the specific resistance of the copper as 1.7 micro ohmic centimeter. So here the first thing we have to note down what is a given data. Okay, so note down the given data that uh, uh, we got length, so L is equals to 100 meters, and we got diameter, so D is equals to 0.05 centimeter, and we got resistivity rho, that rho is equals to 1.7 micro ohmic centimeter. Okay, so micro means we will write it at 1.7 into 10 to the power of minus 6. Micro means 10 to the power of minus 6 ohmic centimeter. So before solving the solution we have to convert all the measurements in a single in a single what units. So now here if we observe, this is in meters and diameter in centimeters and mho is in centimeters. So we have to convert all the readings at the same units, in the same units, so that we can calculate. When we calculate we will get the correct answer. Okay, so here what we are doing, this 100 meters we are converting into the centimeters, because the rest of the units are in centimeters only. So 100 meters is equals to 10,000 centimeters. Okay, so we are converting it into, because we know that 1 meter is equals to 100 centimeters. So by multiplying 100 into 100 we'll get 10,000 centimeters, and D is equals to 0.05 centimeters and rho is equals to 1.7 into 10 to the power of minus 6 ohmic centimeters. Okay, now we have to find out the area. So we know the formula A is equals to pi into D square by 4. Okay, so by we can directly substitute D value in the diameter. So pi into 0.05 whole square by 4. We will get the area, and now we can find out R is equals to rho into L by A. Okay, so here rho is nothing but 1.7 into 10 to the power of minus 6, which is given, into 10,000 divided by area. So we will substitute the area value here. Then we will get the resistance value is 8.66 ohms. Okay, so this is how we have to calculate. First we have to convert all the given data into any one unit, so that we can whatever the solved problem will get the correct answer. Okay, likewise I'm going to tell you one more example which is solved problem. Uh, See here, a silver wire of a length 12 meters and has a resistance of 0.2 ohms. Okay, so resistance is 0.2 ohms, length is 12 meters. And now they are asking us to find the specific resistance of the material. And cross sectional area is given as 0.01 centimeters square. Okay, so L is equals to 12 meters, A is equals to 0.01 centimeters square, and R is equals to 0.2 ohms. So now area is in centimeter square and length is in 12 meters. So any one we can convert into one unit, either in centimeters or in meters. Okay. So here they have converted centimeter square into meter square. Okay. So here 0.01 into, so how we can convert 1 centimeter is equal in meters, 1 centimeter is equals to 1 by 100 meters. Okay. So and this is centimeter square. So 1 by 100 whole square will give you 1 by 10,000, which is equals to 10 into the power of minus 4 meter square. So here area is converted into meter square. And now we can directly substitute the values of R, A and L in an equation. We already know that how we will calculate. We know that R is equals to rho into L by A. So we will find out the rho is equals to RA by L. We will substitute all the given values in this. Then we will get the value of rho, which is equals to 1.666 into 10 to the power of minus 8 ohmic meter. Okay. So this is how you have to calculate the resistance value with the given parameters. Okay, fine. So the next problem is that a length of the wire has a resistance of 4.5 ohms, and find the resistance of another wire of same material, which is 3 times as long and twice the cross sectional area. So you have to understand the question before. So now length we have a length of a wire and which is having 4.5 ohms. Okay. And now we have to find the resistance of another wire which is of same material. So same material means both rows are same. Okay. Row 1 and row 2 both are same with because it is a same material. Okay. And 3 times as long and twice the cross sectional area. So the first wire and the second wire. So we have to understand the question before. The second wire is like that of same material means row is same. So row 2 is equal to row 1 and L2 is equal to 3 times of L1 and A2 is equals to 2 times of A1. Okay. So R1 is equals to 4.5 ohms. So L1 is equals to, okay, fine. L1 is equals to L, A1 is equals to A. Okay. And the second case, R2 is equals to, we have to find out. And L2 is equals to 3 times of the first one. Okay. So that is 3L. And A2 is equals to 2 times of the cross-sectional area of the first one. So 2A. Okay. So we know the resistance R1 is equals to rho into L1 by A1 and R2 is equals to rho. See this you can write it as rho 1 and rho 2 also, ma. As it is of same material, both the rows will be equal. So they have written only rho. Okay. So R1 is equals to rho into L1 by A1 and R2 is equals to rho into L2 by A2. Now we have to substitute the values here. So R2 divided by R1, you have to write R2 divided by R1. And we know that both rows will get cancelled because they are same. And now L2 divided by L1 into A1 divided by A2. Substitute the values here. So 3L divided by L into A divided by 2A. L will get cancelled. A will get cancelled, which is equals to 1.5. So R2 is equals to 1.5 times of R1. So what is R1? R1 is 4.5 ohms. So R2 will become 1.5 times of R1. So 1.5 into 4.5, which is equals to 6.75 ohms. So R2 value is 6.75 ohms. Okay. Right. And the next topic is the effects of temperature on resistance. Okay. So we know that the resistance will also depends upon the temperature. So how actually temperature will affect the resistor? We will see. Okay. So in generally, the resistance of the material changes with the change in temperature. As the temperature changes, even the resistance also changes. Okay. But we have to know how actually it will change. Okay. So the effect of temperature upon the resistance varies according to the types of material. So it depends upon the types of the material. So for pure metals, so I can say it is a conductors. For conductors, the resistance of pure metals, that is copper and aluminum. So I can say even this as a conductors, for conductors. Okay. So for conductors, it is a positive temperature coefficient of resistance. We will call it as PTC, positive temperature coefficient of resistance. Okay. So these materials will have positive temperature coefficient of resistance. It means the resistance will increase with the increase in temperature. So if the temperature increases, the resistance of that material also increases. If temperature increases, R also increases. This is only for the materials which is having positive temperature coefficient of resistance. Okay. So where positive temperature coefficient of resistance will have only to the pure metals, that is for conductors. For conductors, it is a positive temperature coefficient. Okay. And for semiconductors and the insulators and electrolytes, it is negative temperature coefficient. For these materials, it is negative temperature coefficient. So how the effect of the temperature will be? So as the temperature increases, the resistance of that material will decrease. Okay. So the resistance of electrolyte, inductors and semiconductors will decrease with increase in temperature. Okay. That is why this is called negative temperature coefficient. Okay, so negative temperature coefficient. And the resistance of alloys increases with the rise in temperature, but this increase is very small and irregular. So for you people, PTC, that is positive temperature coefficient, and negative temperature coefficients are important. Okay. Okay, right. Now, so what is the temperature coefficient of resistance? What is its definition? The definition is given as like that. The temperature coefficient of resistance. Okay. So the temperature coefficient of resistance of a conductor may be defined as the increase in resistance per ohm, virginal resistance per degree centigrade rise in temperature, or the change in resistance of the material with the temperature is expressed by the factor known as temperature coefficient of resistance. Okay. So this temperature coefficient of resistance is denoted by alpha naught, and its units is degree centigrade or per degree centigrade. Okay. So alpha naught formula is given by RT minus R naught divided by R naught into T, which is per degree centigrade. Here alpha naught, that is temperature coefficient, is equals to rise in temperature, that is RT minus R naught, rise in temperature divided by ohm virginal resistance, that is R naught into T. Okay. So this is given in per degree centigrade. So this is a temperature coefficient of a resistance is given by the formula, that is RT minus R naught divided by R naught into T. Okay. So for here, there is a formula derivation also. So derivation also there. So here RT is equals to R naught into 1 minus alpha naught into T. So this we have to find the resistance at any given temperature. Okay. So this formula will be used to find out a resistance at any given temperature, at any given temperature. So for this solving for this formula, we have to consider a conductor having R naught is equals to resistance at 0 degrees centigrade, and RT is a resistance at T degrees centigrade. Okay, so R naught is, it is a resistance at 0 degrees, RT is a resistance at T degrees, and alpha naught is a temperature coefficient at 0 degrees. Okay, so what is the rise in temperature? The second step is to find out the rise in temperature, that is delta R, which is equals to RT minus R naught. Okay, and is directly proportional to the initial resistance, that is RT minus R naught is directly proportional to R naught, and is directly proportional to the rise in temperature, that is RT minus R naught is directly proportional to T, rise in temperature, that is T. Okay, and it depends upon the nature of the material also. Okay, so it depends upon the nature of the material also. So combining the first two, we get RT minus R naught is directly proportional to R naught into T. Okay, by combining these two, we will get RT minus R naught is directly proportional to R naught into T. Okay, so by taking this proportionality, I'm adding the temperature coefficient. Okay, so RT minus R naught is equals to alpha naught R naught into T. So from this equation, we can get what is alpha naught. Alpha naught is equals to RT minus R naught divided by R naught into T. Okay, which is given per degree centigrade, which is given a per degree centigrade. So units, how the units have come, see here. This is resistance, that is ohm, and this is resistance ohm into degree centigrade. Temperature, it is degree centigrade. So ohmic will get cancelled. So you will get 1 divided by degree centigrade, that is per degree centigrade. Okay. So this is a formula how we have calculated. And from this, okay, so this, yes. So now we found alpha naught is equals to RT minus R naught divided by R naught into T. Okay. Uh, but we have to find out the resistance at any given temperature. So for this, so this is alpha naught is equals to RT minus R naught into T, and reading the above equation, we will get, okay, by this equation, RT minus R naught is equals to R naught into T. Okay, so from this, we have to find out RT. So RT will get here, and R naught will go here. I mean to the right hand side, it will come to the right hand side. So what it will become? R naught, alpha naught into R naught into T plus R naught. Okay. So we will take R naught into common. So R naught into 1 plus alpha naught into T. So RT is equals to R naught into 1 plus alpha naught into T ohms. So we can find out, so the formula to find out the resistance at any given temperature is RT is equals to R naught into 1 plus alpha naught into T ohms. So we will solve one problem on this. So taking here, a copper coil has a resistance of 40 ohms at 0 degree centigrade, and find the resistance of a coil at 50 degrees centigrade, and the temperature coefficient of resistance copper is 0.0043 per degree centigrade at 0 degrees. So first we have to write the given data. Okay, so from this I can say this is at 0 degree centigrade, so R naught is equals to 40 ohms, and T is equals to 50 degree centigrade, and temperature coefficient, that is alpha naught is equals to 0.0043 degree centigrade. So what I have to find out? I have to find out the resistance at 50 degree centigrade. So that is R50, RT I have to find out. Okay. So R50 is equals to how much? So we know the formula already, that RT is equals to R naught into 1 plus alpha naught into T. So directly substituting the given data, we can find out R50, which is equals to 40 into 1 plus 0.0043 into 50, which is equals to 48.6 ohms. So the resistance at 50 degrees centigrade is equals to 48.6 ohms.